we were asked to find the skewness of x being an exponential with parameter lambda. We also asked to explain why it's positive and why it does not depend on lambda. We are also given a hint here to use. So let's define the skewness of x first to really understand what we are after. The skewness of x is, and this is just following the definition of skewness, it's the exponential of the standardization of x. I'm going to write mu of x here to signify that we're using the mean of x, and the same with the standard deviation here, and that all to the power of 3. Okay, so let us first gather what mu x and sigma x is. Well, that is, as always, for an exponential x, 1 over lambda, and the variance of an exponential is always the square. I want to the divided by the square of lambda. And so the standard deviation is just 1 over lambda. So let's use those two facts and simplify this inner term here. So this inner term here would be, or will be, let's just write it up here, and that will be x to minus 1 lambda, and then 1 lambda here over 3. And the inner part of that expression is lambda x minus 1 lambda. So just using the simple rules of algebra, and then let's multiply in lambda here to get lambda x minus 1 with 3. All right, so far so good. Because we want to eventually take the expectation here over this inner expression, let's see if we can simplify by just multiplying out this full term here. Okay, and so that will be x minus 1, and yeah, we're left with x minus 6. Like this, just to make it a little easier without having to remember any rules. And this term will be lambda x squared minus 2 lambda x plus 1. Right? And then we have this term here. We can multiply in this whole expression, so we end up having lambda x. We have now 2 of these, so it will be to the power of 3 minus 2 to the power now of 2, right? We're multiplying this by that, and plus lambda x. Okay, and then we're going to take minus lambda x 2, because we have this minus term, minus 1, and we have plus 2 lambda x, and then minus 1. Well, because I've been taking the minuses here, that's correct. But we shouldn't have a parentheses there. That's what I'm trying to say. And keep on simplifying. If there is anything to simplify, I guess the only thing we can do here is to add these two terms and this term here. Okay, so that's still lambda x to the 3. We have minus 3 lambda x to the 2 plus 3 to x minus 1. Okay, so now let's take the exponential, the expectation over this term and to see what we get here. So we are now, remember, we have just unpacked this term here. Now we're going to take the expectation over this full thing here. So let's continue and wait. So this little star here is a continuation of this here, and we're going to apply linearity of expectations immediately. So, and I'm also going to do to take out, so doing several things now simultaneously. So we take linearity, which means that we can add the expectations over these separate terms. We're going also to multiply out this constant here, lambda, same here and same there. Okay, so we end up having x3, so the expectation over this term, and we have then lambda 3 minus 3 lambda 2, and the expectation over x2 plus 3 to lambda, and the expectation over x, and then we have minus 1, which is still just a constant here. All right, so now we're making some progress, but now we notice that we have, well, this term we know by the expectation over a exponential, so this will be 1 with lambda, and this we also know, which is, well, it's not the variance, no, so we have to just going to make a little mistake here, but those are the two terms that we have to work a little bit more to figure out what they are. And this is where the hint comes in handy, which is that the nth moment of an exponential is in fact factorial. So we can then now let me put a pin in this calculation here. So we're after what this is and that is, and that we rely on the fact that that in the hints basically that the using the MGF of the exponential, we end up having that the first moment is the expectation over x1, which is the first moment, that is going to be 1 factorial lambda here, then the exponential x to the 2, that is going to be 2 factorial lambda squared, should be 1 there to clarify, and then exponential x3 is going to be 3 factorial lambda 3. Okay, so this follows from the hint, but the hint is relying on a combination of using the MGF and the Taylor series to then map the first each term in that expression to see what the exponential is when we multiply out each term. Okay, so that is something we can do in another video, but here I'm just going to use these facts that I outlined. So these are given, these are now given, this one we have already figured out, and this one we write in here. Okay, so let me start by doing that. Okay, so we have now lambda 3, and that is 6, right? Because we have factorial 3 divided by lambda 3 minus 3 lambda 2. Now factorial 2, that's just 2 lambda to the 2, and then we have 3 divided by 1 lambda. Okay, so we are almost there. We're going to now simplify. So we see that this cancels out, this cancels out, and this is canceling out too here as well. Okay, so let me see. I think I have a little error here somewhere. Going to get to it in a moment. Let me just first of all check that this is 6 minus 6. Right. No, we just forgot the minus 1 here. That is what was bugging me. Plus 3 minus 1, and this whole thing adds to 2, which is the skewness of x. And we also notice that this term here doesn't rely on lambda because it cancels out all the way. So that is also what we were supposed to show. And this term will always be positive because we are adding terms here that are in fact always positive.